right, so are you guys able to see my screen here?
I see you.
All right, cool. You should see a bunch of SQL code. Is that right?
I see your slide deck.
Perfect. All right, so that's the screen we're looking at. Perfect. I just wanted to make sure we're which monitor here was being viewed. Uh, okay, great. Well, thank you for having me as part of your group today. I'm looking forward to presenting this topic. It's one that I find really interesting. And the whole point of today is really this, right? So you probably recognize a lot of the companies seen on the screen, and they have one thing related between all of them, right? These are all companies that have at some point either had bugs in their code that opened up SQL injection vulnerabilities, or they've actually had data leaked and exposed, exposing users, passwords, email addresses, personal information on their users due to specifically SQL injection attacks, right? So SQL injection attacks are something that have been around for a long time, and they continue to be a problem today. And looking at the companies that you see on your screen, these are big. A lot of these are big companies with a lot of really smart developers, smart DBAs, and somehow their systems are still vulnerable to these kinds of attacks. So if there's one thing I want you to take away today, it's that there's no one size fits all solution to SQL injection. It is a hard problem. It is very easy to be careless and to open yourself up to the vulnerability. And so over the course of today, I'm hoping that we can eliminate some of those problems and make you better better prepared to ward off SQL injection attacks in your systems. So a couple disclaimers before we really get into it. With the first one being, right, we're going to be looking at a lot of code today, a lot of SQL queries, and I want to ask you only to try running this code at home, right? Normally, that's the opposite disclaimer that you typically see, right? Normally, you hear, don't try this at home. But for today's code, please, if you're going to run it, try it at home, because the last thing you want to do is get onto the radar of someone, maybe if you're trying this at work or something like that, getting onto the radar of security, and they're having to come find you and talk to you about why are you trying to run these SQL injection attacks on your server. So, unless you're in InfoSec or something like that, where it's your job to be, working on these types of vulnerabilities, do this in an environment where you're not going to get yourself in trouble, meaning, not at work. Also, don't try this on other people's systems. Like we saw in that previous slide, these vulnerabilities are out there on the web. I know the first few times that I've that I've seen SQL injection attacks performed, it's really tempting to just go start copy pasting certain queries in all the input boxes you see out there on the web, and that's a really bad idea. Don't be doing this on other people's websites. Don't do this anywhere where you don't have permission to try it. Like I said, I've included demo code. You can try it for yourself, on your own personal machine, see how it works, get really familiar with it. With that said, my name is Bert Wagner. I am a business intelligence developer. I'm a .NET, I'm a web developer. I don't have a formal security background. I just really like tech security. I'm an enthusiast. And that goes back all the way back to sometime around 2001 when I was running my PHP website with a MySQL database on the back end. And I looking at the database logs one day, and I see, what's this funny code, this 1 = 1, what's happening here? And so that's my my first encounter with what SQL injection was, all the way back then, about 16 years ago. Ever since then, I've just been interested in SQL injection and everything else security related. It's just very fascinating to me. So like I mentioned, all the demo code and slides are available at my website. I actually uploaded them earlier today, so you should be able to get them at any time. If you find any problems or anything with downloading them, let me know. But what we're going to go over today is everything SQL injection, right? I'm going to assume some of you know what SQL injection is. Some of you maybe are newer to it. So we're just going to kind of cover the basics, what it is, why it exists, why there's no solution to it, no easy solution anyway, misconceptions that people have about it, and then finally we'll spend a lot of time in demo code taking a look at how we can go about securing ourselves from SQL injection attacks. All right, so the importance of SQL injection, right? There's three big reasons why we want to care about SQL injection, right? And the first one is, I briefly alluded to this earlier, is data leaks, right? Some hackers or malicious users stealing our data. I kind of like to think of a server, both a SQL server as well as the front end, web server, things like that, kind of like a spigot, and we have all the security put onto it to prevent data from getting out when we don't want to. But sometimes that security fails or it's not good enough, just like the grommet or a washer inside of a spigot. Eventually, if you don't keep up with this stuff, that stuff will wear down and you will get data leaks, just like our little water droplet there. So obviously it's really bad from many standpoints of having leaky data out there. I mean, for starters, it's not good for public relations. It's not good for if you're in a regulated industry. Obviously, that's really bad. And then all the moral aspects too of why you don't want to be spreading out your customers' data, right? It's just all around. It's not good. I don't think I need to go into too much detail about that, but that's what we're really trying to prevent today with the different forms of SQL injection protection we're going to take a look at. Another thing, though, to really consider is your data validity, right? So not only can data be exiting your server, exiting your databases in a SQL injection attack, but data can actually be changing on the database, and that's a big problem too, right? So I always like to think about in Ferris Bueller's Day Off, when Ferris hacks into his school. I mean, he wasn't using SQL injection back then in the early 80s, most likely, but he's changing his 9 absences to 0. The same thing can be done a lot of the time with SQL injection, right? Data on your server can change. And so you can't trust your data anymore if you have an injection attack. And that becomes a real problem, right? I mean, you can have a malicious user who, if you're running an e-commerce site and you're selling, I don't know, computer monitors and they're $100 each, if someone goes in there and changes it to $10 and starts buying them, right, that becomes a big problem. Another aspect of SQL injection that people don't really consider is your availability, your service availability. Because you can essentially run any code you want, a malicious user, might not care about stealing your data or changing your data. They might be more concerned about taking down your service. And so, the type of code that they inject, it could be code that's going to, maximize CPU or memory usage. It could be code that's going to lock up the pages, the tables in your database, so no other transactions can, take place. It's not just about stealing data, right? It's about causing, chaos for your service and taking down your service as well. So for all these reasons, right, is why we need to protect against SQL injection. And so I briefly want to talk about dynamic SQL because the whole reason SQL injection exists is because of dynamic SQL. Without it, it wouldn't be around. And the way I hear about, a lot of people have lots of differing views about dynamic SQL. Is it, should you use it, should you not? And I always think back to this picture here. This is from a vacation visiting my family in Germany a few years back. It might look online to you like a bowl of spaghetti with some, tomato sauce and Parmesan cheese there, but that little cookie wafer might look out of place. It actually turns out this is ice cream, right? I guess it's a big thing over in Europe. I don't get it. Doesn't make sense to me. Maybe afterwards someone can explain to me offline about what the big popularity of this is in Germany and other European countries. But when I see this, the thought that comes to mind is just because you can do something doesn't mean you should, right? In my mind, ice cream should be ice cream. Doesn't need to try to be spaghetti. And that's the thought that just because you can doesn't mean you should is what a lot of people think about when it comes to dynamic SQL, right? yes, you can execute dynamic SQL statements, but why would you ever want to, right? You're opening yourself up to all these security issues. There's a lot of other bad reasons for using it, supposedly, right? So why do we even deal with it? Let's not use any of it, and then that'll solve all our problems. Well, the problem is that there are lots of valid use cases for dynamic SQL. For one, you can't parameterize everything. You can use SQL parameters in lots of places, in where statements and things like that. But if you're trying to parameterize things like table names, or if you're running maintenance scripts and you need to parameterize in the names of indexes in databases, you can't necessarily do that with plain old parameterized SQL. The only way to kind of build those scripts is with dynamic SQL, and sometimes that's the only option you have. Additionally, dynamic SQL offers you a lot of flexibility, right? You can write adaptable queries. For example, right? I mean, if you have very normalized data and you want to then be able to pivot it, unpivot it, yes, there are functions to do that in SQL, but you will not have the flexibility that you have if you use dynamic SQL to kind of build those queries. Also, if your result sets need to return different numbers of columns, one of the only ways you can do that is with dynamic SQL. Sure, you can build large if-else statements and duplicate a lot of your queries, but sometimes dynamic SQL is the only way to go. And finally, in a lot of scenarios, if you really are searching for the best performance, you're going to be stuck with writing a dynamic SQL query. Doesn't mean dynamic SQL is always high performance, but in certain scenarios, you might have to write a dynamic SQL query for performance reasons, and because of that, you also need to then be aware of these SQL injection vulnerabilities that we're going to take a look at here in a minute. All right, so with that said, what is SQL injection? So I have this query here. It's pretty basic. Select full name from users where username equals, and then we're concatenating in a parameter. So like I mentioned, a SQL injection attack is always going to be where we have a dynamic string being executed. It's the only way it can happen. And then the key is that we have a parameter that's getting added to our dynamic string that has input that hasn't been sanitized, right? The user is submitting some kind of data. Either the validation wasn't performed on it or it failed. And so a user is able to type in and submit input parameters that we are not expecting, right? And then those unexpected input values are causing our query to do something that we were not originally wanting the query to do. So that's what a SQL injection attack is. So let's just jump over to Management Studio and take a look at some examples. So I've included this code on my website. You can download and play with it yourself if you'd like. But we're going to just create this database here called Injection Sandbox. And we're going to create a table users, kind of like what we saw in that table and in that slide, sorry. If we fill it with some data, we can see we have a few basic columns here. We got full name, we got some serial characters. Obviously, I was working on this demo while eating breakfast one day. So we have the full name of our users. We have their screen names, their usernames, in another column. We have some hashed and salted passwords, so that's a security discussion for another time, but we're okay there for today, so we're not going to worry about that, and a join date. So this is the data that we're going to be going through in all of the rest of our demos today. Pretty easy, pretty typical kind of table that you would see. So what does an injection attack look like in action? So we'll use our database here. We're just going to create our stored procedure, get full name. Like I said, just like what we saw on that slide, we're going to be concatenating in this parm username. So let's just create that procedure. And let's see one example, right? So this first example is how we would intend our procedure to get used, right? We're going to pass in a username, and the procedure is going to spit back the full name of that user, right? Maybe to display in the corner of the website or as part of a login process, right? Whatever. Now, our query is injectable with this syntax here, right? So if we pass in our username, we don't need to pass this in necessarily, but if we then add in an escaped quote with or 1 equals 1 dash dash, what happens is our query returns something that we did not expect to return, and that's all of our full table of users' full names, right? So we're not only are we seeing Toucan Sam, we got all these other guys coming back too. And the reason that this works is because when you pass in this string into the dynamic SQL query that the stored procedure is building, this is the query that gets built. So instead of just passing in a username, we've decided to then finish that part of the query and then add our own where condition here, right? Or 1 equals 1. And so 1 equals 1 is always going to be true, which basically then eliminates this first username equals condition, allowing the entire table worth of results to come back to our query, right? And our dash dash is then just commenting out the rest of the original dynamic SQL string. So this is a very common pattern you will see in SQL injection attempts because it's pretty easy to test out a database, test out a query to see if it is injectable. And so we'll be using this pretty often throughout the rest of the demos to show how different techniques either are successful or error prone to injection attacks. So that's a really basic example of what SQL injection is, how it works. Obviously, it can get way more complicated than that, and a malicious user can find out a lot more data, right, than just the full names of users in our table. So just one more quick example to show you is if we take a query like select star from system objects, right? So system objects is a view containing all of the tables here on our server and our database, and we could easily join this then with other sys tables for extracting column names and things like that from the database. But if I run that with 4XML path, what it's going to do is give me the entire result set from sys.objects in a single row, single column, right? Same data, just now we're looking at it as a single large XML string, making it very convenient to pass back to something like a website. Because that's the thing you got to remember is, with these injection attacks, if a user is trying to get at this information through, let's say, a web portal or something like that, if the website is only returning one row of data, they need to be able to get that data back in one row. And so this might be one way that they can do that. And so, another injection example that we have here is we can put that select star from sysobjects 4XML path as part of our injection query here, when we're just joining to it with a union. And so what that'll do to our injectable procedure is return back our 2 rows. Because we're doing a union, there's a sort in there, and our less than sign gets sorted before our T, so our first row of data is going to be the entire database view of all table names, right? So with SQL injection, it gives the attacker a lot of information about what our database looks like. So those are the basics of how SQL injection attacks work. And so let's hop back to the presentation here. So we already looked at that. Oh, let me switch views. Sorry about that. There we go. And so, why is this still a problem? So I want to just go back in time a little bit. I was trying to find, how far back do SQL injection attacks go? And the earliest kind of reference I could find online was to this, this hacker ezine back in 1998. And you could see even back then, SQL injection was already kind of a documented problem. So you can see this is from December 25th. Someone got a nice Christmas present to learn about SQL injection attacks. And you can see they're using the same sysobjects kind of query that we were just demoing a second ago. And obviously, SQL injection existed even before 1998. This was just an easy to find kind of visual to use in a presentation. But for as long as you've been able to kind of execute a dynamic statement in SQL Server, injection attacks have existed. And this became a much bigger issue, as time went on, especially in, the early 2000s when we had the whole Web 2.0 phase and every company wanted to get their, store, a web presence, and e-commerce really started to pick up. And so, companies were building websites with stores and lots of SQL database calls were happening, and no one knew anything about security. I shouldn't say no one knew anything, but a lot of people were not taking security into account in building those sites. And so to kind of combat that, a group of individuals created the Open Web Application Security Project, or OWASP, and they decided to build a list of the most vulnerable web vulnerabilities out there. And what they came up with, right, they didn't have any data at the time of, in the real world, what are the actual highest vulnerabilities. So they just created their own list. And in that list, they did include injection flaws. And so that doesn't only include SQL injection, it includes other types of injection as well. But it does include SQL injection. And even back then, they knew that it was a serious problem. So then throughout the years, OWASP, kind of every few years, if you're not familiar with the organization, they take surveys. They actually now collect data to see, in the real world, how frequent are these different types of attacks, which ones truly are ranked the highest, and injection flaws kind of has risen in the ranks over the years. And in 2013 was the most recent year that OWASP released their list, and it was #1, right? And so now they're actually doing, they're planning on doing another release by the end of the year. So this isn't the final release, last I checked when I was putting the slide together. And this didn't make me a little nervous. It was funny because I'm like, oh, I'm putting these slides together. I'm giving a talk on SQL injection. What if SQL injection isn't a problem anymore, right? So this is the authority on ranking these vulnerabilities based on data of how often these vulnerabilities result in attacks in the wild. What if SQL injection is a problem anymore? Well, it turns out, right, even though this isn't the final release, SQL injection is still ranked #1, right? Injection attacks in general, including SQL injection. So this is still a problem, right? Even back in the 90s, this was a problem. Even today, this is still a problem. And I think there's a few reasons for that. And I want to just briefly mention the common misconceptions of why SQL injection still exists. And it exists because of these misconceptions, because I think a lot of people don't realize that they are at risk. And so the first one, right, is just that the misconception people have is that the structure of my database isn't public. And whenever I hear this, whenever someone tells me this, I'm kind of a jerk about it a little bit, but I like to tell them a story about, I guess, my teenage years. I used to be a magician. The amazing Bert, there I am in floral Hawaiian print doing a magic trick. And I tell them, okay, the structure of your database isn't public, but let me do a magic trick for you, because that's what I used to do in my previous life. And then I say things like, oh, so okay, your database structure is private, but do you have any tables that are called things like users or products, sales, inventory, right? Just because the structure of your database isn't public doesn't mean that it's not easy to guess, those structures. There's a famous saying in security that security through obscurity, isn't a thing. It doesn't work. And so that's true, right? You don't necessarily need to have your database public to be able to guess what a lot of these table names are. I mean, as we saw in those queries, you can also do things like query sys.objects to actually find the names of tables and columns. So just hiding that information from the public doesn't mean that you're secure. All right, another misconception here is I obfuscate my table names, right? So this I hear from people who want job security in all the wrong ways, and so they generate their SQL tables to be called crazy things, like instead of products, they call it AZ2538, which, side note, if you do this, please stop. It's just very annoying, and it doesn't actually increase your security. And the reason for that is, right, like we mentioned, it's pretty easy to query something like sys.objects or in sys.columns to actually get the structure of your database. It's easy to inject that type of query and to get those table structures out of the database. So it doesn't matter if your tables are called something crazy. I could still just iterate over them and find out what data belongs in them. It may take me a little bit longer, but not much. Additionally, just because those names aren't common doesn't mean you're not going to accidentally reveal those through other means, right? So that's what this other screenshot here is it's just a stack trace dump from a .NET web app. Obviously, you shouldn't be showing these kind of debugging screens to users, but I have seen plenty of them out in the wild on the web. It could just be a developer forgot to turn those, those screens off. It could be that your logs are made public, anything like that. It's very easy to make a mistake. It's hard to code for every scenario. So it's, even though you're not trying to actively show people your database, that information can come out. It's not necessarily secret. All right, I know, so we're talking here, we're a bunch of SQL developers, a bunch of SQL DBAs, so isn't it just easy to say that SQL injection is a developer's problem? They should be, validating their inputs and cleaning up the input on their end. And while I agree with you, 100% the developer should be doing that, SQL injection, along with many other security issues, is best solved with multiple layers of security. So while your developer should be cleaning their input data and they should be sending it to you already validated, that doesn't mean that you just don't have to do anything, right? It's our job too to be doing all that we can to protect ourselves, because that's the only way you're going to be able to prevent most of the attacks. And just as an example, right, here's another picture of me from way back when, before I followed better coding standards. But I mean, a lot of developers will just do JavaScript validation, right? Purely front-end JavaScript validation. Well, it's not going to help you if someone turns off JavaScript validation in their browser. And obviously, there's more layers than just front-end JavaScript validation, but if there's a will, there's a way, and there's ways to get around a lot of the validation that developers do. So you always want to be responsible for your own code and preventing SQL injection on the back end. And finally, another misconception is just, I'm not important enough to get hacked, right? So maybe you own a garden gnome e-commerce website, you've only got a couple hundred customers, which I have to say for, I guess, a garden gnome business, it's probably pretty good, but you think you're not important enough to get hacked. And to that, I just say, it doesn't really matter, because if someone wants to get your data, they're going to get to it. There's automated tools that are indiscriminate to the size of your business that are going to try to inject and find vulnerabilities in your website to steal your data, right? So one example is SQL Map. It's a great tool to test a website for SQL injection vulnerabilities. And I know that IPv4, it should be, we should be on IPv6, but most websites, most everything is still on IPv4. It's pretty easy to write a script to just loop over every IP address and run automated SQL injection tools. So a hacker or a malicious user isn't necessarily looking for your garden gnome website, but if they find it and they find that it's injectable, why not steal your data? I mean, it's a big problem, right? So it's not that these injection attacks are necessarily being crafted by hand. They can be automated, and no one is safe, right? No one's too small from prying eyes from a malicious hacker, or even just some bored teenager, right? On a Friday night, they're stuck at home, they're not doing anything. What better thing to do than just fire up some Python code and start scanning for SQL injection vulnerabilities? Not saying that I ever have done that. Like I mentioned, the disclaimer, don't do that. All right. So finally, for the rest of this session today, I want to go over a lot of the different solutions that we have in SQL Server for protecting against SQL injection. And just another disclaimer up front is that really none of these are going to prevent SQL injection attacks just by themselves, except for maybe not writing dynamic SQL. But these are best used in combination with one another, and so we'll go through those now. Okay, so. And I'm going to kind of go through these examples with the ones that I think are the most effective to maybe the least effective, or the ones that you need to be most concerned with and careful with if you decide to use them. And so solution number one is very simple. And I'm not trying to be a jerk here, but just don't write dynamic SQL queries. And I say this, right, knowing full well that there's many reasons why you would want to write a dynamic SQL query. But if we jump back to my first demo of a SQL injection attack, right, where our query looks like this doesn't need to be a dynamic SQL statement. This could very easily be represented just with nice SQL code with parameters that aren't being concatenated in, right? And so you are protected from a SQL injection attack. And I know that this sounds like, well, duh, right? Who would ever do that? And I just say this because, you know, you're probably not the only person writing queries against your database. You might have people with a more, you know, developer-minded background where writing a query like this is just, that's how they know how to do it. Based on their programming background, right? Whatever language or tools they're used to using, this might be how they do write, you know, their SQL queries, and they have to build their strings dynamically, and there's no better way of parameterizing those queries rather than just concatenating values in. So the first thing, right, you should do is just check and make sure, does your query actually need to be parameterized, or does it need to be dynamic SQL? Because a lot of the time, these queries might not need to be dynamic SQL. They could just be regular SQL queries. And as you'll see, if we create this get full name safe procedure here, as long as, you know, we're not using dynamic SQL, our query is safe from SQL injection. We run our injectable query here that we saw works in our dynamic SQL case. Without dynamic SQL, we will not get SQL injection. So it's just very important that you first consider, do you even need to have dynamic SQL? All right, step 2, damage control. So I highly recommend that you do this on all queries that accept user input. And it doesn't have to be maybe at this level, but you'll see what I mean in a minute, right? So what we want to do is we want to create a user in our database that's going to execute our stored procedure. We want that user to have very limited access to what they can do, right? So here I'm going to create this user called limited user, and the only permission I'm going to give them is to allow them to run select on our users table. So if we go ahead and we create that user, we can then, any stored procedure that we have that is using dynamic SQL, and we know that we need to use dynamic SQL, right? So this demo here is a little contrived, right? In this case, yes, we don't need to use dynamic SQL. Just play along with me that let's pretend this procedure does need dynamic SQL, and we are passing in our unvalidated user input. So as long as we have this with execute as limited user, we're going to limit the access that the user has. That's executing the stored procedure, so that if someone does inject a query into here, it's going to severely limit what they're able to do. Right. So let's just create this procedure, and we'll take a look at that in a minute. All right. So this query here is obviously it's injectable. So creating a limited user account isn't going to prevent injection, but what it will do is, well, so first of all, it'll allow regular queries to go through, no problem. If it tries to do something like, if a malicious user tries to get the structure of our database by querying sys.objects, since the query is injectable, they will get a result. But the thing to notice here, if I copy this XML code out to another screen, is that you'll see this XML code is very short. The reason for that is it's only giving us information about our one users table here. They don't see everything else in the database because of our restricted access. So in that type of attack, right, they're not going to be able to go access, even if you find, if an attacker finds a vulnerable, input field on your website or in your app, they're only going to be able to query the one table that you've restricted the access to, right? So in the case of this injection attack, it'll still work because we are doing a dynamic SQL concatenated with an unvalidated input parameter. So that it's not going to prevent injection, it's just going to limit what else an attacker can see. So like I said, none of these solutions you want to use by themselves, none of them are foolproof, but limiting the access that a stored procedure has in executing to what tables it has access to, right, is a great first step. So then what else can we do, right? After we limit access, we can use potentially SP execute SQL. So if you're unfamiliar with SP execute SQL, what it does, and we'll just, let me create this stored procedure real quick so we have it. What we can do with SP execute SQL is have a SQL query string, and you could see we have a parameter named inside of it. So that means this query string we could be generating through code or in some dynamic way. And then what SP execute SQL will do is it'll search that code for any parameters that you specify and actually parameterize that query for you. So we're passing in our full query variable into SP execute SQL. We're also passing in a definition of what parameters our dynamic query has. So here we've defined that our SQL query has a parameter called username and its length, varchar 100. And then we're actually passing in our parameterized values. And so what this will do is you're basically getting the benefits of dynamic SQL because we're able to generate this query on the fly programmatically, right, however we need to, but we're still getting parameterization. And there are some other benefits of SP execute SQL too, right, with dealing with query plans, getting into the cache and things like that. But the key here is this is a parameterized query that is now safe from SQL injection. So if we pass in a value to our stored procedure that's expected, things work like we would expect it to. And if someone passes in an injectable query string, it doesn't work, right? Because what SQL Server is then doing is it is looking for a user called tfly37 quote or 1 equals 1, which doesn't exist, and our query is safe from injection. Now, the only problem with SP execute SQL is it follows the rules of parameterization that are in SQL Server. So you won't be able to do something like this, right? So here we have a next stored procedure. Let me just create that, right? We're going to try to parameterize our table name because sometimes that might be something we want to do. And so I define my definition of table name. I pass in a value for table name as well as user. We still kept user there. If we try to run it, you'll see we'll get an error message. And that's because with SP execute SQL, you still can't parameterize things like table names. You can only parameterize things that can normally accept parameters in SQL Server. So what are we to do? In that case, we can do something like use the quote name function, right? So let's say we need to parameterize our table name. Let's use quote name. Now, quote name will basically, it'll escape characters by default. It's going to add brackets around any input value that gets passed into it so that it's suitable for a database object. You can also have it escape things like quotes by specifying a second parameter. There's a couple different values you can use there. But in general, we're going to use quote name without the extra parameters. We're just going to add brackets around our input parameters. And so what that's going to do is, let me just create this first. So here we go. Here's our dynamic SQL query. Here's our string. We're concatenating our parm table name along with the quote name function wrapped around it. So that's going to add our brackets and make things safe. And then still for other parameters that don't need, that are in locations in our query string that can just accept parameters in SQL, we're still going to use SP execute SQL for those. But in this case, we can pass in a value for our table name parameter and things will work, right? So we passed in our user's table name and things work and it's safe, right? So now if we try to pass in a value like users, semicolon select from DBO users in an injected attempt here, you'll see that it fails because SQL doesn't find a table called DBO users select from users. So that prevents SQL injection attacks. The only downside there is that quote name limits output to 128 characters, right? So if you have input parameters that need to be longer than 128 characters, you're going to need to do something else. And I've included a link here in the code to some examples of what you can do. But obviously it gets a little messy. It's not as easy as just putting the quote name function into your code. it opens up the possibility for writing code that doesn't prevent injection. So really, I try to stay away from that as much as possible. All right, so now we're going to take a look at some additional ways of preventing SQL injection, which can work if you implement them properly. I mean, I guess in all these examples, they're only going to work if you implement them properly. But these next two, I get really nervous about them because it's much easier to implement them incorrectly and open yourself up to injection. I'm showing this here with a full disclaimer that this solution is not foolproof. And we'll take a look at some fun examples here as to why it doesn't work. So I think this is really interesting. I think you'll find it really interesting too. So we're going to continue with our query here. We're passing in our table name and our username as input parameters. And we're going to use replace to write our own string sanitizing function, right? We're going to take our table name and we're going to find any occurrences of a single quote and replace it with 2 occurrences of single quotes, right? And so if you're not very familiar with writing dynamic SQL, I know this looks a little crazy with all the single quotes that are in here, but basically we have our 2 single quotes on the outside that are indicating the string input. And then in order to specify a single quote value here, we need to escape it with another single quote. So don't let that bother you too much. We're basically just taking every single quote in our input parameter and replacing it with 2 single quotes. So if we create this procedure, we'll see what happens, right? So the idea here is if we escape our quotes manually, any SQL injection attacks won't work because this is doing something similar to what quote name would do. So here's our very much injectable query, but because we think we're correctly sanitizing our data, we think this is okay. And in some cases it will be, right? So obviously in our first case where we are doing just a regular, appropriate input values, things work like we expect. We only get our 1 row. In certain cases where the injection attack involves a single quote like this, right, our or 1 = 1 attempt, things still work. Our replace function, our custom sanitation function here, works great, no problem. The problems begin with other types of injection attacks, right? And this is why I mentioned this whole section with replace, because I see in a lot of code replace being used as like the only form of protecting against SQL injection. And while it works for some specific scenarios like this, it doesn't work for all scenarios. Like here where we don't use any single quotes in our input value. We just do another select statement. And so in this case, right, not only are we getting all the full names from our user table, but our second query is executing and returning our entire table of data. And in this case, right, we have our hashed passwords too, as well as other information. So it just goes to show, right, that writing your own escaping function with replace, doesn't necessarily protect you from all different kinds of SQL injection attacks. And we'll take a look at one more example with replace here in the next set of demos that I think is really interesting. But before we do, I just want to go over one more technique that you can use, and that's sanitizing your inputs on the SQL side of things. So yes, your developer should be sanitizing their data, but you can also do some sanitation and validation on your side. And once again, this is not foolproof. This is just an extra layer that you can add, but don't expect it to work in 100% of scenarios, right? So let's take our query here. We have username getting passed in, it's varchar100, and let's create that stored procedure. So that one's called long input, and the differentiator here is the length on our input parameter type. So then we have another stored procedure we're going to create here called get full name short input. And the big difference, at least one difference, is that our parameter username input is just length 6. And so let me create this, and we'll take a look at the rest of that in a second. But as long as you're following good coding practices, so if we know in our database that the username should never be longer than 6 characters, for example, so tfly37 here, is 6 characters long. If we know that we're not allowing users to generate usernames longer than 6 characters, we shouldn't be allowing users to input 100 characters of input data, right? It's not a valid use case. And so in this stored procedure where we allow the long input, right, it becomes a problem because a user can write injection code and it'll run. However, if we try that same attack on the stored procedure where we have correctly defined the data type and the length of our username parameter, right, the injection attack gets prevented because after the first 6 characters of our username, the rest of this data gets truncated. Now, that's not to say that it's impossible to inject any type of code into that stored procedure. Especially 6 is very short, right? If your parameters do have to be 30, 40, 50 characters long, you're going to have a hard time with this. But in certain scenarios, right, if you're looking for very short input, or maybe it's just like a number, a single digit, type your data correctly, because then it'll prevent these types of SQL vulnerabilities from getting in. And so the other thing, right, I mentioned, if you're expecting numbers or something like that, you can do some of your own validation. So the second stored procedure here, our short input stored procedure, not only is it correctly defining the data types and lengths of our input parameters, but we can do some basic validation here. So we're saying if our usernames, if we know only letters and numbers are allowed, we can filter out if our username has an input that's not a digit, or if it's not alphanumeric, let's just return our stored procedure, not execute our query, because it's possible that other characters are SQL injection attacks. And so if we then try that out, right, if someone passes in just an alphanumeric string, it's going to try to run the query, right? There's no username called T37, but you can see we're actually getting the structure of our stored procedure result set back here with just full name. But if we try to type in an invalid character, right, which may indicate SQL injection, our stored procedure will just not return anything. It just instantly returns null. And so once again, this isn't going to protect you from injection. It is very easy to write code that is not 100% defensible against SQL injection attacks, but this is just one more layer that you can do, right? In certain scenarios, if I know I'm expecting a 3-digit number, I can validate that my input is a 3-digit number to prevent any unforeseen scenarios. So then the one more demo I want to go over, I know we got 10 minutes here, so this will work out perfectly, is what's known as a homoglyph attack. And this is one that even people familiar with SQL injection I don't think are always aware of. And this gets at the problem of trying to write your own validation sanitation functions, right? So given the scenario, let me create this stored procedure here. We have a query, an injectable SQL query. We're concatenating in our username parameter into the rest of our query. And we think we're going to do a good job by writing this replace function, replacing single quotes with sets of 2 single quotes. And the key thing here to be aware of with this type of injection attack is this will only work, this specific homoglyph attack that I'm about to show you is only going to work when we have an implicit conversion happening. So you might notice that in my input parameter here, my username is nvarchar, but my query field type is varchar, right? So it's non-Unicode. So we have our Unicode parameter being concatenated to our non-Unicode string. You may say, Bert, why would you ever mix data types like this? And my response is, it happens a lot, right? If you need proof, go query, right, your server to see how often implicit conversion is happening, how often developers don't correctly type all their variables, and this data type mismatches happens all the time in SQL. Trying to be good and helpful, instead of just failing the query and rejecting it, it will do some automatic implicit conversions to let you see your results. So this specific attack we're looking at now only works when you have an implicit conversion happening from Unicode to non-Unicode, but I think it's really interesting. I think you'll be surprised to see what happens, right? So given that query, once again, we pass in our regular value, no problem. We get our data back, 1 user, 1 row, like we expect. If we pass in a value where we write an injection query here, using a single quote, right, which is getting replaced, right? So there we go. Just to remind you, it's there, it's getting replaced, right? In this case, our query works as expected. It does prevent SQL injection. It works. However, if someone now passes in a Unicode character, so this highlighted character here is an apostrophe, it is not a single quote. What SQL will do is, because this apostrophe doesn't exist in the plain, ASCII character set, it's going to convert it to a SQL quote. And so, even though we wrote our replace function, that query is still injectable because SQL replaces an apostrophe with a single quote after our replace function during the implicit conversion that happens when we're concatenating our parameter to the rest of our dynamic SQL query string. And so, right, that's where the homoglyph comes in. When a character that looks like something else is known as a homoglyph. So in this case, an apostrophe looks like it resembles a single quote. So that's the homoglyph injection attack. And so, right, if we look at that explicitly, if we're casting our apostrophe character or Unicode apostrophe character to both a Unicode data type and a non-Unicode data type, it might be tough to see here. But in this example here, this is no longer the apostrophe. This is now the single quote in SQL Server. And so the whole point of showing you this attack is that I just want to make it very clear that it's really, really hard to write any kind of custom code to try to clean up data and have it work 100% of the time, right? Use all those other techniques that were good with SP execute SQL and quote name and just not writing dynamic SQL. If you have to write a replace function, then be really careful, because these kinds of, that opens up the possibility for many different creative attacks to happen. And just to show you, right, I wrote this little script here. Let me run it because it takes a second to run. Basically, we're looking for all homoglyph characters in the Unicode character set. So that's where this number comes in. That's the number of Unicode possible characters. And once this returns, right, here we have our Unicode character column, and here we have our ASCII representation, the homoglyph for that character. So 39, 59, those are our true single quotes and semicolons. And I just picked semicolon here because that's another typical character you see in injection attacks. But here you'll see we have all of these other characters, which are Unicode-only characters that SQL will convert to plain old single quotes and semicolons, right? So these two characters here, they may look alike, but they're really not. And this is the big problem with writing your own custom functions. It's that, you have to account for all this stuff, and that's really hard to do securely. And the problem with something like Unicode is, right, the Unicode character set isn't full yet. So even though you might write something today, which is 100% safe, a year from now, if there's additional Unicode characters that exist, it might not be safe anymore, right? So it'd be something that you have to maintain and update, and it just becomes a nightmare to try to do. So just as a final example here, right, if I decide to write some custom validation function that says, okay, I'm going to replace my quotes, and I'm also going to replace any words any input parameters that contain the word select, because I don't want them selecting additional data from my database. If someone is passing in an input value that contains the word select, I'm going to strip it out because I know that that is likely an injection attack. And the problem with that becomes then, here we go, right? Here's our Unicode version of select instead. Obviously, right, we got S with an accent and these funny E's and L's and all these other Unicode-only characters that don't get caught in that replace function. But when the implicit conversion happens, going from Unicode to non-Unicode, whoops, it might help if I select the right database here, and let's just recreate that, right? There's our injection attack. It works. Even though we're stripping out, or we think we're stripping out, keywords like select or maybe update or delete, there's ways around that. It's very difficult to write secure validation code. So finally, I've included one more demo script here. We're not going to run it because this is my test server. I don't have anything. But if you're wondering, right, where does do I have SQL injection code on my server somewhere? So I've written two queries, one that goes against the SQL modules view, and one that goes against your cache execution plans that look for queries that might be injectable. It's not 100% accurate, but if you have a new server that you're running, that you're taking ownership of, and you want to see what exists on it, this won't catch 100% of cases, but this might be a good way to start instead of having to go through hundreds of stored procedures one by one to see if injection vulnerabilities exist. You can just run these queries to give you an idea of how big of a problem it is. So with that said, we'll just wrap up with the presentation here. Oh, and this keeps on swapping screens. There we go. So other tools exist, like I mentioned, SQL Map, not only used by hackers, but you can use it for yourself to test vulnerabilities against your server. More and more products, right? So Azure SQL, I've only played around with it in development environments, but there's now a nice little slider there that you turn on, and it will supposedly protect against all SQL injection attacks. And from what I've tried, it seems like it works pretty well, but I haven't used it, in a production environment. So I don't want to give my full backing to it or anything, but it's cool that security, that these injection attacks, right, injection vulnerabilities are being considered now in software. I'm hoping that's a trend that continues, that more tools in the future will have more automated means of protecting against injection attacks. And then finally, right, this is a big problem for you. There are other monitoring tools available that will monitor, right, the queries and the inputs hitting your database. It'll profile, right, valid input values coming into your query, so that if something looks out of whack, that something might be an injection attack, right, it'll just shut down. It'll kill that query. It'll prevent it from running. So if you need to, right, lots of banks and things like that will use tools like that to monitor for SQL injection attacks. So those are out there if you need them. So just to summarize, right, there's no easy one-size-fits-all answer to SQL injection besides just not writing dynamic SQL. If you need dynamic SQL, though, you need to be validating your user inputs, both on the development side of the house as well as the database side of the house. You always want to limit the privileges of the accounts that are executing your stored procedures, so that even if an attacker gets in, it limits what they're able to access. And then obviously you can use software and other things to find additional vulnerabilities. So that's it. Good luck. Thank you all for attending. My name is Bert Wagner. You can, I put the demo code for this presentation as well as the slides if you want to reference any of them on my website. If you have any questions, hit me up on Twitter or at my email. I'd be happy to chat about SQL injection or other topics. And that's it. Thank you very much. Thank you, Robert, for hosting.
Thank you, Bert. We appreciate you presenting for us today. We did have one comment that come in for that. Tim Cartwright has a project on GitHub that's basically a better quote name. That you use it like quote name, and it has additional protections against SQL injections. So people may want to check that out. But otherwise, thank you for presenting for us today.
Yeah, thank you. And that sounds like a really interesting project. I'll have to check that out. What was the name of that again, Robert?
Well, I was given the link to it, which is has a GUID in it, but so it doesn't tell me what the name is. But it's on GitHub, and it's a project by Tim Cartwright. So I assume you can find it by looking for projects by Tim.
Great. Sounds good. All right. Well, thank you very much.
Thanks everybody for attending.